All right, Algebra 2 peeps. I'm going to take the Module 3 practice test, so let's jump into it. Okay, looking at number 1, it says factor completely. So remember, rule number 1, is there a greatest common factor? And it looks like there is. 3 goes into 33, and 3 goes into 84. So if I factor out a 3, I've got x squared minus 11x plus, and let's see, this would be 28. 28 times 3 is 84. So now it says factor completely, so we're not done factoring yet. So we've got a 3, and this is going to break up into factors of x something, right? We need factors of 28 that add up to 11. And since this is a negative, this is a positive. They have to both be negative. So 1 and 28, 2 and 14, with all of them being negative. 4 and 7. Oh, there it is. X minus 4. Negative 4 plus negative 7 is negative 11. Negative 4 times negative 7 is positive 28. So I need to look for this one. There we go. What is the factored form of this? Again, rule number 1. If I pull a 5 out, I've got x to the third minus, and what's 135 divided by 5? 27. What have I got now? Oh, look, this is a difference, and these are both cubes. That's a cube, that's a cube. So this would be 5x minus 3. And remember, the rule is if we have difference of cubes, this going to have the same sign. The next one's going to have the opposite sign, x squared plus, multiply a and b together, 3x plus 9. Because you got a equals x and b equals 3. And we just plug it into the factoring shortcut that you should have in your notes. And we're looking for that. 5 times x minus, well, this is the one that has 5 times x minus 3 right there. X squared plus 3x plus 9. Hey, we're good. What is the axis of symmetry for this? This is the parabola, so it's a positive number. We know it's going to be a upward parabola. So the axis of symmetry is right in the middle, and it's going to go through the vertex. So it's going to be an x equals equation. What is the vertex? Well, remember, HK is the vertex. X minus h squared plus k. 2, 1 is the vertex. So this must be the line x equals 2, because that's the point. 2, 1. X equals 2, first choice. What is the y-intercept? Oh, this is the easiest one they've given us, because the y-intercept is like right when it's on the y-axis, and when it's on the y-axis, x equals 0 on the y-axis. So if x equals 0, that's 0, that's 0. That's all that's left. So must be the point 0, 12, because y would equal 12. Okay. The following graph of f of x equals x squared has been shifted to x minus h squared plus k. What is the value of h? Well, let's see. It's been shifted to the right 4. So in order for this to be shifted to the right, it'd be x minus, right? Because minus shifts it to the right. So h must equal 4, which we have as a choice right there. H equals 4. All right. Solve. Okay, so that means find an x that would make this equal to 0, right? Now, if we look at our choices right away, I've got a big hint that this is best use of the quadratic formula, because it's not going to factor and end up with answers like that. So the quadratic formula is x equals negative b. This should also be in your notes. b squared minus 4 times a times c all over 2a. And so in this, we got a equals 1, because that's what the coefficient of the x squared is. B equals 4, C equals negative 4. A, B, C, the coefficients. So let's plug it in and see what the answer is. Negative B, negative 4 plus or minus the square root of B squared, 4 squared, 16, minus 4 times 1, so that's just 4, times negative 4, all over 2 times 1, or just 2. So if we simplify, negative 4 plus or minus 16 minus negative 16. That's the square root of 32 over 2. Square root of 32 is the same as, it's the same as the square root of 16 times 2. So we could say the 16 and the 2 is separately. So this is 4 square roots of 2. So this is negative 4 plus or minus 4 square roots of 2 over 2. So we can take a 2 out of all three factors. So this is negative 2 plus or minus 2 square roots of 2. A lot of 2's. Negative 2 plus or minus 2 square roots of 2. That's what it simplifies down to. I mean, you can write that. If you can't see that, you can always remember, you can always separate the fractions. And then you can see when you separate the fraction, you can see, well, 4 over 2 is just 2, and 4 over 2 here is just 2. So that simplifies that to negative 2 plus or minus 2 square roots of 2. It's just simplifying it. Factor completely. Well, remember rule number 1. We can pull a 5 out of there, which leaves 4x squared plus 8x plus 3. Okay, so this, we look at that and say, well, take the coefficients 4 and 3, multiplies together. So we need something that multiplies together to be 12, but adds together to be 8. Well, 12 is 1 and 12, 2 and 6. Oh, wait, 2 and 6, that equals 8. So let's factor by grouping then. 4x squared plus 2x plus 6x plus 3. See, I just took 8x and I made it a plus 2 and plus 6x. I didn't change anything. I just rewrote it differently, right? Because 2 plus 6 is 8. So now I can group it. What can I take out of 4x squared plus 2x? Well, I can factor out 2x, which leaves 4x squared divided by 2x is 2x. 2x divided by 2x is just 1. Plus, what can I take out of here? 6x plus 3. I can only take a 3, which leaves 2x plus 1. Oh, look at there. Both these factors have a 2x plus 1, so I can factor it out. So I got 5 times 2x plus 1. And what's left? 2x plus 3. So, oh, there it is. 5 times 2x plus 3 times 2x plus 1. Doesn't matter what order they're in. You can multiply in either order, but that is the completely factored version. All right, describe the translation as y equals negative 5x plus 2 squared minus 3 from the standard position. Well, the standard position would just be y equals x squared, right? So what's happened? Well, we know it's going downward and it's being skinnier because of negative 5, but it doesn't care about that. It just wants to know how it changed position, not how it changed shape. This is how it changed shape. So x plus 2, well, it's x minus h squared plus k, right? Where hk is the vertex. So if x minus h, but that's 2, so this must be x minus negative 2 in order for it to be x plus 2. So that tells me that h is negative 2, right? Oh, and the k is minus 3. So from the origin, this went left 2 because it went to negative 2. Remember, the positive, it goes the opposite direction. So this went left 2 and down 3. Up, down 3. Here's this. Down 3, left 2. That's the one we want. The other choice was down 3 and right 2, but we know it didn't do that. And we can eliminate the up 3s right off. All right, so what is the factored form of this equation? Maybe it's not factorable at all. Let's see. Well, we got to take the 3 and the negative 12. It's going to be negative 36. And we need the factors that would multiply together to be negative 36, with the larger one being a positive, since we're going to end up with a positive. So let's see, 1 and 36, the larger one being positive, negative 2 and 18. And we're trying to end up with a 5 when we add them together. Let's see, negative 4 and 9, negative 6 and 6. This is 35 adding together. This is 16 adding together. Oh, this is 5. Okay, so let's rewrite this. And instead of 5, let's make it minus 4x plus 9x minus 12. So I took the plus 5 and I made it a negative 4 plus 9. Grouping. Well, in fact, I'm gonna just because grouping would work better, I'm going to put the plus 9 first and the negative 4 second. Just because 3 and 9 factor and 4 and 12 factor. You can write them in either order. You do negative 4 plus 9 or plus 9 negative 4, but either way, that's plus 5. I'm just looking for better ways of grouping. So 3x comes out of there, which leaves x plus 9. And what comes out of there? Negative 4, which leaves x. Oh, that doesn't leave x plus 9 because I factored 3 out of 9. So that's just a plus 3. And when I factor negative 4 out of negative 12, that leaves a plus 3. So this term and this term both have an x plus 3. So it's x plus 3 times 3x minus 4. And they put the 3x minus 4 first over here. So 3x minus 4 right there, x plus 3. That's the two things we need to multiply together. That is the factored form. It would have worked the other way. I would have just factored out the 3x plus 4 have been left in there, 3x minus 4. But I wanted to just change those to make it a little easier there. Factor completely. All right, let's see. 8. I'm thinking of rule number 1. That's a 2 or a 4 can pull out of that. 21 is only a 3 and a 7, so there's not a greatest common factor. So first and last, 80. Everything's a positive, so I don't need to worry about negative numbers. So I need to add up to 21. So 1 and 80, 2 and 40, 4 and 20, 5 and 16. Oh, that equals 21 right there. So I can make this 8x squared. Let me erase it. I want that to be a negative 8. 8x squared. Instead of 21, I'm going to make it a plus 5 plus 16. And this time I'll do it this way. X plus 10. So I could have swapped these two again because the 8 and the 16 work good and the 5 and the 10 work good. But I'm going to leave it this way just to show you can factor it either way. All I can factor out of this is just an x, right? Which leaves 8x plus 5. Because all the factor out is just an x. Over here, what can I pull out? All I can pull out is a 2 plus 2, which 16x divided by 2 is 8x. 10 divided by 2 is plus 5. Oh, look, 8x plus 5 is in both of those. So this is 8x plus 5 times what's left? X plus 2. Looks like it's the first one right there. X plus 2, 8x plus 5. Yep. All right. I think we're about halfway through. I think there's 20 questions. Yeah, we'll get there. Factor completely. Oh, look, this is 4 terms. So let's just go ahead and say group it. So what pulls out of there? Well, there's a 2 and a 10, so we can pull a 2 out. There's an x squared and an x squared. We can pull x squared out of both terms. There's a y to the fourth and a y to the first, so we can only pull a y out. So what's left? 2x squared y to the fourth, and we pull out 2x squared y. That leaves only y to the third, and we divide that out. Minus, we're going to divide 2x squared y out of here. We got 10x squared y. Oh, so that just leaves negative 5, because negative 10 divided by 2 is negative 5, and these all equal 1. X squared divided by x squared, y divided by y. So that's what we get. Now we got plus 14 y to the third minus 70. Well, 14 and 70, we know we can pull a 7 out of there. This has a y to the third that doesn't have any y's. So all we can pull out is 7. 14 y to the third divided by 7. Well, that's just... Oh, wait a minute. Will 14 go into that? 14 will go into that. Wait a minute. Because I want to end up with y to the third. So looking at that, I can pull 14 out of there because 14 times 5 is 70. So if I pull that out, I just have a y to the third like I had here. And minus 70 divided by 14 is minus 5. See, because I know that I want to have the exact same term in both of them, so I can factor that out. So now that is y to the third minus 5. And what's left when I factor that out? Right here, 2x squared y plus 14. So I'm looking for 2x squared y plus 14. Maybe it's prime. And y to the third minus 5. What? Oh, no, they factored another 2 out of here. Look, we have a greatest common factor here we can pull out. We could have pulled a 2 out at the very beginning. So if we factor 2 out of here, 2 times y to the third minus 5 times x squared y plus 7. We could have done it at the beginning and saved ourselves some trouble, but as long as at some point we factored out. So I see a 2 is factored there. 2x squared plus y plus 7, y to the third minus 5. It is this one right there. Factor out the 2. What is the vertex of the graph of this? Well, remember, it's x minus h. So the h is negative 2. The k is plus 5. So that's the vertex. Negative 2, 5. Oh, that was awful nice of them. Give it in vertex form so we can just find out what the h and the k are. That was really nice. All right, solve this. Well, again, I see we can either complete the square or use the quadratic equation. But either way, we're going to end up with a square root in our answer. So let's use the quadratic equation. So let's set this equal to 0 first, which means I'd have to subtract 24 from both sides. So now it's in ax squared plus bx plus c. So a equals 1, b equals 8, c equals negative 24. X equals negative b. This is 8 plus or minus the square root of b squared. So that's 64 minus 4 times a, which is 1, which is 4. I mean, a is 1, so 4 times 1, and then negative 24. All over 2 times a, which is just 1. So x equals negative 8 plus or minus 64 minus 4 times negative 24. So 4 times negative 24 is negative 96. So minus a negative means we're adding these together. So this is the square root of 160 over 2. So 160. What squares can we take out of there? Well, let's see. Let's break down 160. So I'll go up here where I know I don't need any space up here. 160. So 160 factors to 2 and 80. Or 4 and 40. 4 and 40 is pretty good because we know we can take the square root of 4. All right. So what does 40 break into? 4 and 10. Well, that's good. We can take the square root of 4 there. So that must mean, oh, we could have just went 16 and 10. 16 and 10 is 160, right? And the square root of 16. So x equals negative 8 plus square root of 16 is 4 square roots of 10 divided by 2, right? Negative 8 plus 4 square roots of 10 divided by 2. So let's split these up. Negative 8 over 2 plus or minus 4 square roots of 10 over 2. All right, that's what x equals. So x equals negative 8 divided by 2 is negative 4, plus or minus 4 divided by 2 is just 2 square roots of 10. So there we go. Negative 4 plus or minus 2 square roots of 10. Great. Factor completely. 3x squared minus 36, not 3, 36x squared minus 121. Well, I see that difference in there. Is this a difference of squares? 36, that's a square. That's 6 times 6. X squared, that's a square. That's x. So this could be 6x and 6x. 121. Yes, if you remember our chart, that's 11 squared. So this is 6x plus 11, 6x minus 11. We just used our shortcut of a difference of squares because we looked and said these are both squares. These are perfect squares, so we can just use our shortcut. And that's this one right here. It didn't print my little circles over here, but it's that one. All right, moving right along. Oh, it didn't print any of my circles anywhere. I don't even know what number I'm on, but that's the last 3 pages here. Okay. So that was number 14. This is number 15. Number 15. I'll put it up there. What is the factored form of 64 x to the third plus 343? Oh, let's see. I think these are both cubes, aren't they? Let's see. 64. I suspect they are. I know 64. If I put it in my calculator, let me clear that out there. If I go second, I can take the cubed root right there in my calculator. So 343. I know 64. The cube root of that is 4, right? Oh, it's 4. 64 cube root is 4. See, 4 times 4 times 4. But what about 343? It's like, oh, I seem to remember that was on my chart. Cube root 7. 7 times 7 times 7. Okay, so this is 4x cubed. Let me get rid of the calculator so you can see it. 4x cubed plus 7 cubed. So this is a sum of cubes. So we can use our shortcut. So for our sum of cube, 4x is our A and our B is 7. So the shortcut that we have in our notes says the factors are 4x plus 7 because it has the same sign. And then we have the, let's see, 4x squared, which would be 16x squared, right? 16x squared when I square those. And I know I've got a plus 49 at the end because I square that. And this would have the opposite sign. And when we multiply those together, we get 28x. So this should have the same sign. This should have the opposite sign. So let's see, 4x plus 7, 16x squared minus 28x plus, oh, it's the first one right there. There's our choice. Using our shortcut of just finding our A and B and putting it in the pattern. Squaring the A, squaring the B. When I square the A, I get 16x squared. When I square the B, you get 49. All right. Oh, this one is definitely a quadratic equation. Look at that. It's got I in it. So this is an imaginary solution. X equals negative B plus or minus the square root B squared minus 4AC over 2A. So what's our A? Our A is 9. B is negative 12. And C is 6. So X equals negative 12. So it's a positive 12 plus or minus the square root of B squared. Negative 12 squared is 144 minus 4 times 9 times 6. All over 2 times 9. Okay, we're going to want that calculator back now. So let's bring the calculator. And we're going to calculate. First, let's just write this. X equals 12 plus or minus over 18. And let's calculate what that underneath the square root part is. 144 minus. And I'm going to put all this in parentheses so it multiplies everything together. 4 times 9 times 6, parentheses. Negative 72. All right, so we need to simplify that now. So negative 72 is negative 1 times 72, which is negative 1 times 36 times 2. We like those numbers because all of this is under the square root, right? Well, we can take the square root of 36 and we can take the square root of negative 1. So this is X equals 12. I'm going to break them up right here and we'll see if we want to leave them that way. Plus or minus. So this is 6i square roots of 2. 6i square roots of 2 over 18. All right, 6i square roots of 2. Because this is 6 and this is I, and this has to stay. We can't take the square root of 2. So this is 2/3. X equals 2 over 3 plus or minus. And this 6 over 18 is 1 over 3 I square roots of 2. So if we put it back together, X equals 2 plus or minus. Oh, and there's a 6 out there too. 1 times 6. Oh no, it's just a 1 because the six got dissolved in there. So it's just I all over the 3. The 6 over 18 is 1/3. So 12 over 18 is 2/3. So they both have a 3 on the bottom. I can combine them back together since they have the same denominator. So 2 plus or minus I squared to 2 over 3. These are negative 2, so we can cancel that out. This is the 3. This is the one that even has a 2, so it's definitely that one. 2 plus or minus. When we saw it was 2 in the front, we could have eliminated those without even finishing it. So, all right, what is the factored form of this equation? All right, nothing common that we can pull out. 7, 2, and 5. Those are simple to get. So let's see what equals negative 35, because that's 7 times negative 5, but adds together to be 2. So let's see. Negative 1 times 35. Negative 5 times positive. Oh, that one does it. That's 2. So let's write this as 7x squared. And I got a, instead of 2x, I got a plus 7 and a minus 5. So I'm going to put the plus 7 first. And a minus 5x minus 5. Oh, see how nicely that's going to factor when I group it. So this is a 7x, which leaves just x plus 1. This is a minus 5, which leaves x plus 1. So this is x plus 1, 7x minus 5. Right there. 7x minus 5. All right, not much left. Got a graphing one. Use the graph to solve for the average rate of change from x equals -2 to x equals -1. We'll see, when x equals -2, here's the x. The graph equals 7, right there. 7. And when the graph x equals -1, the graph equals 5. So minus 5, and the graph went from -2 to minus -1. So the graph changed to -2 minus a -1 is +1. So the average rate of change must be -2. Well, we can check that because that average rate of change just means the slope. So let me connect those 2 points. What's the slope of that line? Well, that's easy. It's on a graph. So it's -1, -2. It went down 2, and it went right 1. So the rise over run, oh, it is -2. So right there, -2. Love it when they give us a graph and ask us for the slope. We can just look at the slope. -2 over 1. All right, solve by completing the square. Oh, yeah, we haven't done that. So let's write it down over here. Equals -12. Now, the first thing I see is I can go ahead and factor out a 3. Well, let's leave it. Let's factor it out later because we'd have to factor on both sides. Let's just make this simple and just say we'll leave it like it is for now. We'll factor it out of this side for now. X squared minus 8x, just to simplify things for us, equals -12. So remember, completing the square, we take the middle term here, -8, and we cut it in half. So it's -4. And then we square that and add it to both sides. So we're going to add 16. But we didn't just add 16 this side because everything inside these parentheses is being multiplied by 3. So we actually added 48 to this side. So we're going to add 48 to that side to balance it. That's the only way we can have the same on both sides. Since we added 16 inside the parentheses, we're going to add 48 over there. So now this is a perfect square. This is x minus 4 squared, which we did on purpose. And it equals -12 plus 48, 36. Okay, we're not trying to write like the vertex form. We're trying to solve. So we're trying to get this down to just x. So let's divide both sides by 3. So we have x minus 4 squared equals 12. And now we can take the square root of both sides, right? So we got x minus 4 equals the square root of 12, which I'm going to write as the square root of 4 times the square root of 3, because that's 12. So x minus 4 equals 2 plus or minus, right? Because 4 could be plus or minus plus or minus 2 square roots of 3. Move the 4 over to the other side. So x equals 4 plus or minus 2 square roots of 3. Right there. First one. 4 plus or minus 2 square roots of 3. All right, we have one problem left. The following graph of f of x equal x squared has been shifted to x minus h squared plus k. What is the value of k? Well, we know the vertex is going to be hk. We know originally when it's just x squared, that means that the origin was where the vertex was. It got shifted right 2. It got shifted up 3. The vertex is now at the point 2, 3. And we know k is the y value of the vertex. So k equals 3. They made that one too easy on us. All we have to do is look at the vertex. We know the k is the y. So since the y is 3, k is 3. All right. I hope this helped you. If you struggled on any of it, went back and watched what I did on that with the explanation. If you still don't understand something, get with me. Come to class or email me, and we'll get together and make sure you understand. Do well, guys. Do work you can be proud of.